Wind turbines displace hundreds of kilograms of carbon dioxide. I did the math. It's 4,000 to 8,000 times more mass per megawatt hour for coal generation than it is for wind turbines. But you can't take a picture of it.
Hi, everyone. Welcome to the Climate Confident podcast. My name is Tom Raftery, and with me on the show today, we have our Vancouver correspondent, Michael. Michael's been on the podcast a couple of times before, but for people who don't know you, Michael, would you like to introduce yourself?
Tom, thanks for having me back to describe myself. I had to accept the title of climate futurist a couple of years ago. As a Canadian, it felt very pretentious, but I have a habit of arrogantly doing projections through 2100, decade by decade, of major climate change problem areas and the solution sets as they grow and change over time as I figure those things out. I spend most of my time looking at purported solutions to problem areas based upon the trifecta of: will they actually technically work? Will
Mhm.
they be economically competitive with other realistic solutions? And will human beings accept them? My stuff tends to be grounded in money, science, and human beings, which is, most people kind of miss some of those.
It's kind of important, I would have thought. But why do you do that, Michael? Why do you spend your time modeling 40 to 80 year decarbonisation pathways instead of reacting to the next quarterly headline?
Because I'm a broad spectrum, just can't help but know. I end up running into questions and I don't know the answer, and I go, what the heck's the answer? And then I figure it out, sometimes from existing peer-reviewed science. I do a lot of literature reviews. Recently, for example, I went back and tested my hypothesis around maritime shipping. My hypothesis around maritime shipping and my projection for that space is that all inland, most short sea shipping will go to battery electric, and then the crossing oceans will be hybridized with batteries used for national waters, ports, mooring and berthing, and biofuels used to cross the distance. And so I went and said, okay, so what does the literature on batteries for maritime shipping say right now? And what I did when I looked through, I think it was 8 studies, was I found that they all obsoleted by the plummeting cost of batteries and the increase in energy density of battery energy storage systems,
Hmm.
and the change in chemistries. So they were estimating $300 to $400 per kilowatt hour of storage when we're seeing $65 per kilowatt
Hmm.
hour of storage coming out of China. And they were asserting massive volumes and weights when we're seeing much more compact frames and higher energy densities at the pack level. And so they were all right directionally to be looking at batteries for maritime shipping, but wrong by a very significant percentage. And so I found after that literature review that my thesis that I arrived at a few years ago was strongly supported by the direction of travel of batteries. So that's something I do. But most people don't wake up in the morning and go, this was the opinion I published. Am I right? Or am I just out to lunch? I just had that question, so I went and looked.
Just on that, seeing as you brought up maritime, it's interesting. Two questions come out of that in my head right now. One is, what happens to using ammonia slash methanol? You're saying biofuels. Will there be enough biofuels created to do all the transatlantic shipping that we're saying we need to move to?
So A, yes, and B, we're going to need a lot lower amount of fuels than you think. So there's a bunch of analysis being done now. Thankfully, somebody is doing it besides me. When I pulled together my data set of inland, short sea, and blue water shipping, that was the only unified data set I could find. I had to do it myself a few years ago because I couldn't find one. Now people are starting to publish on container shipping. What they're finding is feeder container ships are representing 50% of all of container ship, and that means that they're actually doing a lot more short sea shipping. And so the ratio of short sea to deep water shipping is different than most people assumed. So that's kind of statement one. The second thing, though, is that 40% of all of shipping tonnage globally is of coal, oil, and gas. And obviously, most of that is going away. We're still going to be using methane, fossil methane, as a feedstock for some things where we don't have enough biomethane available. We're still going to be using petroleum or crude oil as a feedstock for petrochemicals, where we don't have biological alternatives. So we're maybe at 15% of oil. Coal is just going to go away, and natural gas is probably going to go away. So we're not going to have LNG shipping. So that's 40% of tonnage gone. And then another 15% is raw iron ore, mostly steaming to the same ports the coal is going to in China. Well, China's at the end of its infrastructure boom. Steel and cement and concrete are off there already, and it's transitioning its economy away from that. And it's 50% of demand. We have a lot of different methods. About 50% of all steel is used in infrastructure, and now finite element analysis for efficient uses of technology or of buildings to minimize the materials or as a service to anybody who wants to design a building anywhere in the world. So buildings in Indonesia, India, Africa are going to be much more efficiently designed simply because that's going to be cheaper and it's easy to do now. And of course, we have alternatives. One of the reports I published last year was on mass timber. Right now, we can take mass timber, which is basically plywood on steroids. One of the ways you do is you take an entire log from a trunk of a tree and you put it on a spindle, and you got this big razor blade that just peels off a couple of millimeters thick laminate off this thing as it's unspooled. So you get that with this long, you just kind of put it, cross-grained. So you take one and then put another layer on top at 90 degrees and another layer on top at 90 degrees. And you just end up with this and you glue them all together, about 3% epoxy by mass. And you end up with this very strong structural member that's very light. And so when we say strong, they're actually building a 50-story mass timber building. And when I say that, that means the structural beams are mass timber. The walls are mass timber. The floors are mass timber.
Wow.
And they're manufactured like Lego in factories and trucked to the site. So steel and cement still required. We have steel rebar in the foundations, and we have cement and concrete in the foundations. But it's a lot less. We might have steel fasteners, although they're actually using, in many cases, a specific fastening mechanism that avoids rusting steel components in the wood in many cases. So you end up with no steel in the structure. Now this gets better because mass timber is about 5 times stronger than reinforced concrete. So you need a ton of mass timber replaces 5 tons of concrete and steel in reinforced concrete.
Right.
That means, once again, the foundation has about a third the cement and concrete as well, because it doesn't need to be as strong.
Sure.
And when you drive the components, they're so much lighter, you end up with a lot fewer cement trucks and steel rebar and stuff going to site. So you end up with a lot less road waste and a lot less energy. Here's one of the interesting things. If you look at a big building site, it takes about a week per floor because they actually have to wait for the beams, the structural members, to set hard enough to support the weight of the building above them. Concrete isn't instantaneous. It takes about 28 days to get to building intended strength, but about 7 days for the structural members to get to, you can put the next floor on strength. But with mass timber beams, small group of carpenters, you put them in place, you lock them together, you put the floor on, put the next floor on, you put the next floor on, you put the next floor on. You can actually get an entire building's skeleton put up in about a fifth the time. Another benefit story, every ton of mass timber, instead of being a carbon bomb, every ton of mass timber actually embodies a ton of carbon dioxide from the air. It sucks in the carbon dioxide, breathes out the oxygen, keeps the carbon as a building block for the wood. And so you end up with, depending upon how you do the carbon accounting, you've got a ton of sequestered CO2 in your building instead of tons of CO2 emitted making the reinforced concrete. And so we have all sorts of forests globally. I've spoken to mass timber executives with plants in Uruguay, and they actually receive BIM models, CAD models with lines for every component, and they manufacture them and they router out the windows, they router out the lines for where the electrical lines will go, they put in the doors, the frames, and so you just get this panel delivered and you put it in place, and it's got the cutout for the stairwells and it's got the cutouts for the elevators and stuff like that, and you just slap them in place. One site I looked at was the case studies of that last year. They had a team of 6 assembling a 12-story building. It was just 6 people, and there were a lot fewer trades. I mean, you think about a standard building for the construction. Well,
Mhm.
you need experts on bending the rebar and building the frames. So you need carpenters for the wood frames for pouring the reinforced concrete. You need people who deal with the cement and building and wiring that together or putting the mesh down. You need the cement people themselves. They come in with the truck and the concrete, the trucks, and you've got the people who know how to pour and they know that stuff. And you've got some other trades. But in mass timber, you got 5 structural carpenters or 6 structural carpenters. So you need a smaller group of skilled resources to achieve the same structural stuff. And then, of course, after that, you've got all the flooring, wall coverings, cladding, windows, wiring. You've got all that in the plumbing. All that stuff is the same set of skills. But when you're building the building, when you're actually putting up the structure, it's a smaller group of trained skills and it's a lot fewer people. So lots of advantages of that. And the reason I lean into that is one of our big levers for reducing our global concrete and steel demand. I'm actually rereading a book right now that's great, The Material World. One of the things they talk about is steel equity. So you and I, Tom, you on the outskirts of
Seville.
Seville, thank you. I was gapping on my Southern European city. You and me in Vancouver, we have an average in the West of about 15 tons of steel. And in the developing world, they have a ton or two of steel. That high-speed train that you can take takes a lot of steel.
Yep.
The condo building I live in took a lot of steel. The water filtration plant I depend on and you depend on took a lot of steel. But the mass timber story says, wait a minute, 50% of steel is for buildings. What if the buildings are mass timber and have a lot less steel? And they last 80 years, they're durable, and we can do great stuff with them after they're done. The point there is there are other levers that will displace steel, and so we won't see, and that finite element analysis I mentioned earlier
Mhm.
will also reduce the amount of steel required to achieve the lifestyle we have. So the lifestyle of the future for the developing world won't be nearly as carbon intense with embodied carbon as ours is.
And what about, I mean, you mentioned the pillars through which you examine these things. You didn't talk there with mass timber about the economics.
Oh, so right now it's scaling, but we have in Canada alone 700 mass timber buildings now. It's definitely scaled. In early buildings, it was about 20% more expensive, complete end to
Mhm.
end. So that's within range. As soon as
Yep.
you start having carbon pricing mandates, as we do in Canada, for the amount of kilograms of embodied carbon per cubic meter, and you start ratcheting those down, or carbon pricing the cement, the price point ends up being very equitable. The report I did last year was a policy plan for Canada. So
Mhm.
Mark Carney came in, one of those global leaders who lucky to have as our prime minister now. And one of his signature policies is, well, dealing with our housing crisis. Some of the ways he has to deal with the housing crisis are negative because we've had to cut immigration because that was causing us challenges. Some of it is reducing foreign students because that was swamping our rental stock. But the third policy is that he's going to lean into building multi-unit residential buildings for the bottom 20% of people, public housing. And it's going to be mass timber, modular development. They have a bunch of pre-designed buildings that you can choose from depending upon the site you have. And they'll go up faster because they're more standardized, but they enable a regionalized supply chain that is efficient and has scale for mass timber. A problem with mass timber modular construction in the West is people have been playing around the edges with residences, like people's homes,
Mhm.
and trying to do that. And that worked in Palm Springs, by the way. If you ever get to Palm Springs, there's this 2,500 detached homes that are all built from the same kit, but they don't look like cookie cutters because they designed it in such a way they could rotate the building 90 degrees or 180 degrees on the lot. And so you'd go down and you'd see different facades and different ways building, and you could rotate the roof on the building as well. So the building actually went together. That inside it was all the same, but the outside looked different. So you drive through these neighborhoods, and it looks like an interesting division of modernist homes that all look relatively different, but they're all the same thing. That was a mass modular housing thing that actually worked, unlike a lot of them that didn't. But multi-unit residential buildings, you're getting into a lot more scale. So in British Columbia, where I am, I'm going to be speaking in Burnaby in a couple of weeks. Well, Burnaby is a place where we had a modular industry, but we didn't have a baseline financial model for it to continue to operate on. But billions of dollars from the federal government for a housing policy creates that. So now what we can do is we can actually create a sensible, regionalized mass timber modular industry. And as soon as you have that with a baseline federal customer, then it becomes available at an attractive price point for other development. And so we have that proof point. That then becomes the model that can be used anywhere in the world where you actually have a timber resource. And it actually adds value to the timber resource. Now, most of British Columbia's logs get turned into wood pellets to be burned in Europe, stupidly, or they get turned into single-use paper products, or they get shipped to Asia to turn into single-use chopsticks, or in some cases, we actually ship raw logs, which is just dumb as a box of hammers. There's no value add there. And oddly, right now, we're suffering because guess what? Trump put a tariff on softwood lumber products for construction in the United States out of Canada. But a modular mass timber industry that's high tech, that's higher margin, that serves the northeast of Canada with modular things, then it gets a lot more money, which can then invest in the forest resource. And so a mass timber thing, a strong regional added value, enables something which is good, which is forestry sustainability. So all sorts of excellent things, but this is why this is an industrial policy paper I put together last year. And one of my levers in my cement decarbonisation model that I put together a few years ago through 2100. But I didn't understand it well enough. So I returned to it and did a deep dive last year. And I'm publishing a whole bunch of articles on different portions of it, and then people correcting live and die by post-publication humiliation, or people suggesting that I really need to look at this topic as well. I ended up with so much stuff that I ended up assembling. I think it's a 130-page white paper with examples of around the world that have been done in mass timber. Some of them are gorgeous. There's actually one, I think it's one in Barcelona. They've actually got this structure. It's cloud-shaped mass timber that's made with intersecting mass panels, and it's out over this square. And it's just gorgeous floating structure that provides shade in a hot climate.
That's here in Seville.
It's in Seville. Okay.
It's in Seville. Yeah. It's called the setas, and setas is the Spanish word for mushroom. So and you can go up through it and onto the roof and walk around, and you get fabulous views of the city from it. And it is I think it's the largest structure made completely of wood in Spain, if not Europe.
So you've actually experienced it in person. I've only seen pictures.
That's gorgeous. Yeah.
And that's part of the new story of this stuff, because globally there's a tendency to think of public housing that's built to a specific plan as being soulless, soul-destroying, ugly, and falling apart. But mass timber with modern technologies enables make them interesting inexpensively, right? The modularity and the factory manufacture, you're not spending a lot of time with skilled trades doing stuff on site. You're doing a lot more stuff in the factory. And so you can actually select different kits, put them together in different ways. And, we're doing one in Vancouver on this kind of sloping land that's hard to develop. But now out of this stuff, they've kind of got this terraced set of developments. They're going to have 20 units capable of, I think it's sleeping up to 80 people. So there's, beds for 80 effectively in this space. And it's just going to go together a lot more cheaply and it's going to be actually interesting, attractive housing. So mass timber actually works out pretty well. It's been fascinating to listen to the cement people talk about, well, concrete enables a thermal load, which is advantageous for heating and cooling. And no, it's not. Modern condos that are made of concrete and have balconies, one of the things that's hilarious is the balconies actually jut out and typically don't have a thermal insulator. So you're radiating heat through your balcony, or you're internalizing heat if it's hot outside into your unit.
Wow.
So you're heating and cooling your floor at the wrong way. And that's because of the nature of reinforced concrete and most building codes. You actually have to have a thermal cutout there that most building codes don't require. So better comfort, healthier environment, lower impacts on the neighborhood and the roads, lower impacts on climate, faster build, better regional economy. There's just nothing wrong with it.
And to get back to the original point, that means there'll be fewer ships.
Oh, yes, the ships. Sorry. Maritime shipping, less 15% of raw iron ore degrades to maybe 5%. But even there, what we do is we do a lot more processing into iron close to the mine. If we take the Pilbara region in Australia, where Fortescue has massive mines, Australia is the biggest exporter of iron ore in the world, by far. After them, Brazil. One thing that Brazil and Australia have in common is that where the iron is, there aren't a lot of people and there's a lot of empty space, especially in Australia. And there's a lot of sunshine. And so you can hammer in special purpose solar and now cheap Chinese batteries, and you can put in place all the stuff and you can do modern steel practices. Depending on where you are, you can do biomethane, direct reduction of iron, or you can do molten oxide electrolysis, which is an electrochemical process for reducing, derusting iron ore, or maybe you can even use hydrogen, although I think hydrogen is going to be a lot less competitive compared to the alternatives. I did a bunch more stuff on steel last year, so there's a bunch of different ways we can make iron and then get the iron we need. But we're going to be making the iron where we have abundant, cheap electricity and iron ore, and shipping the iron, not the iron ore. So it gets rid of about 50% of the bulk is gone right there. And then we're going to be seeing a reduction in terms of iron demand and steel demand because China's past its infrastructure boom, and the other developing economies don't have the structural requirement for the massive amounts of infrastructure China built, and they have new alternatives. So 40% of fossil fuels being shipped across oceans diminish, 15% of iron ore being shipped across oceans diminish. Well, we're down to 50% of tonnage. Then you've got a lot more of it electrifies, and so you need a lot less liquid fuels to cross oceans than we require today.
Yeah.
And this is an economy where more people actually have more energy.
Yeah. I saw an Ember report came out talking about, and this is not news to anybody who knows anything about energy, but primary energy, 2/3 of it is wasted. Only 1/3 of it actually goes into useful work. And most of that useful work is either heating something or moving something. Those are the two main brackets of work that are done by energy. And the rest is lost to waste. So as we move away from fossil fuels, because when we go to electrifying everything, it's far more efficient, the amount of energy we actually will require will only be about 1/3. Well, it'll probably increase as we electrify more stuff, but maybe a half of what we're using today.
I've done the analysis, so I'll just lean on that because I'm just going to say Mark Z. Jacobson was modeling that in the 2000s. Another guy was modeling that in the 2010s. Saul Griffiths, under Department of Energy contract in the United States, found the same thing. I did the napkin math in the late 2010s myself against Lawrence Livermore National Laboratory stuff to find the same thing. And we all come to the same thing. It's like we need, for exactly the same energy services, heating stuff or moving stuff, we need about 40 to 50% of the input energy in an electrified economy where we're using renewables, because renewables are a lot more efficient than burning fossil fuels for electricity, right? When you burn fossil fuels for electricity, you're creating heat to move something, a spinning turbine, and you lose 40 to 70% of the energy in the fossil fuel because it's inefficient. But a
Yeah.
wind turbine, we don't care if it's inefficient because we're not harvesting the wind. We're not paying for the moving air. And we're not paying for in solar panels, we're not paying for the sunshine hitting the solar panels.
We were talking about electrifying everything.
Yep.
And if we think about that, one of the countries that's going gangbusters on that is obviously China.
Mhm.
Is China's strategy more about climate or industrial dominance?
Or energy security or energy affordability. It's not one or the other. I did a seminar series through the India Smart Grid Forum a couple of years ago. Basically, 13 seminars delivered virtually, thankfully, to India's electrical utility people. And one of the topics was energy security. The same thing keeps coming up. The electrons you make from wind and sunshine inside your borders or in your coastal waters are highly secure.
Hmm.
A container of solar panels delivered from China lasts for 30 years and prevents shiploads of natural gas from being required from places that are of dubious reliability. United States.
I didn't want to say it.
But that's kind of the point is one of the things I started to talk about years ago, one of the questions people had was for high voltage direct current HVDC between countries, well, doesn't that just externalize an energy dependency? And I said, yes, up to a point, but it's a two-way thing typically for most of these interconnectors. You've got excess electrons locally, you ship them through the interconnector to the other end, and vice versa. But two, the term I coined was strategic energy interdependence. If we look at Europe, Germany and France share terawatt hours of electricity every year. Spain, where you are, shares terawatt hours of electricity with France every year. And so, for a continent full of states like Europe, that makes sense for strategic energy interdependence in Europe. It makes sense for Ireland to put offshore wind in the Atlantic and get advantage of all those massive winds and to flow that electricity in. When I was working with TenneT, the Netherlands transmission system operator last summer, they brought me in, they flew me through the clear air turbulence over the Atlantic to help them for a week of workshops to create a pragmatic 2050 energy scenario for the Netherlands so they could do their target transmission plan based upon something that made sense, that didn't have, for example, hydrogen as an energy carrier. Right now, the Netherlands is the gas station for Europe. Crude oil tankers arrive at Rotterdam and other ports. They get refined into petroleum products of various types, petrochemicals, mostly fuels. 70% of the jet fuel in Europe comes through the Netherlands. It's manufactured in the Netherlands.
Wow.
And so, you kind of like look at that and go, well, that's going to change. Not as much as we'd like by 2050, but it's going to change. But offshore wind turbines built off the coast of the Netherlands, HVDC through to Germany, feeds clean, low-cost electrons to a massive consumer. And so instead of being the gas station for Europe, it's the offshore wind transmission and distribution system for Europe. All right. And once again, strategic energy interdependence. People who have offshore water availability for offshore wind share the electrons, not only for their own economies, but for other economies. But still, stuff's going to change. And actually going to change where you are. I'm going to give you an example, something we stumbled across 2 weeks ago. So there's an announcement in the Financial Times that China had built something like a third of the full capacity of aluminum manufacturing in China was now clustered around the big dams in the southwest, near the Three Gorges. Aluminum, you're turning bauxite into alumina, then you take the alumina and you put in enormous amounts of electricity, about 13 megawatt hours per ton of finished aluminum. And China had, of course, makes more aluminum than any other country in the world combined. Like 60% of aluminum manufactured in the world is manufactured in China. And up until a few years ago, it was manufactured in the Northwest, where there was lots of bauxite that could be turned into alumina, that could be turned into aluminum, and there's lots of coal. And so all the aluminum, all those 13 megawatt hours per ton of aluminum were coming from coal. Well, around 2012, the Three Gorges Dam was opened, and then other dams were opened. It was mostly clustered in the southwest. And then China started building aluminum foundries in the southwest near those things.
Hmm.
And they were shutting down the worst of the aluminum foundries in the northwest and replacing them with higher efficiency ones as well. So it wasn't an either or. Guess where they're building a lot of wind and solar? In the northwest. Aluminum is one of those things you can just keep recycling it, right? And so now they're at 11 million tons a year of scrap they're turning into recycling, and they're probably going to get up to 25 million tons a year, which is a lot. And so they peaked in terms of total emissions from aluminum manufacturing in 2024, and it's going to go down steeply. The stuff that's still manufactured in the Northwest is going to be more and more green electrons. They're going to be doing more and more scrap, which is more green electrons. They're going to be maintaining the hydro stuff in the Southwest because they've kind of peaked stuff there. And aluminum is an infrastructural thing, so their infrastructure demand is going to diminish as well. So the combination reduces the total thing through 2040 quite a bit. I said that there's a connection to where you are in Spain.
Yep.
And the connection is a lot of industrial capacity in Europe right now is clustered where, well, Russian gas used to flow. So there's cheap Russian gas coming through pipelines.
Mm-hmm.
And now those industrial centers of Central Europe are suffering from high energy prices and are challenged economically.
Yep.
But Spain has all this sunshine and wind and cheap electricity. I did test this because there is a clear pathway for the cost of electricity for consumers, whether industrial, commercial, or residential, to get cheaper over time with renewables and more electrification. Basically, you maximize the use of the wire infrastructure. And if you get twice as many electrons flowing through the same wires, the cost of that infrastructure per kilowatt hour is halved effectively.
Sure.
And if we put batteries in to soak up peak electricity and shift that to peak demand, well, we reduce the amount of wires we have to build.
Mm-hmm.
And we can do that with transmission, we can do that with distribution. If we do demand management to soak up more electrons into electric vehicles at night and into heat pumps during the mid-afternoon and the solar peak, do all those kind of sensible things, well, we end up with a 60 to 80% utilization that's much flatter for the grid. So we don't have to build nearly as much. We utilize what we have much more efficiently, because right now we're at 30 to 50% in the West utilization because we build for the peak.
Mm-hmm.
And so the cost of the infrastructure for the electrons goes down, and we're using a lot more wind and solar. They're setting the marginal cost of electricity, wholesale cost of electricity a lot more. So the wholesale cost of electricity goes down. And so there's kind of this virtuous energy cycle for those things. And China's already starting to see it, by the way. They're maximizing electrification.
South Australia as well are seeing a lot of, where they have huge renewable resources now in South Australia and huge batteries. And so they're starting to see there's a huge backlog of demand by industry for electricity because they all want to move there because they're getting clean, cheap electricity. Another question for you, though.
One more thing on Australia. 3 hours of free electricity in the afternoons in many states. Charge your car there, do your laundry there, do your dishes there, right?
Yeah.
So,
yeah. Amazing. The big issue, of course, with all these renewables is they'll all fill loads of landfill, right? You wrote an article about that.
I've written 2 articles on that. It just continues to piss me off. So, a related story. Why do people blame wind turbines for health impacts?
I would say it's because they're new and they're not used to them, and anything we fear change.
Yes, and you can see them.
Yes, yeah.
Friends of mine like Fiona Crichton and Simon Chapman, who are PhDs of public health and the psychology of transformation in New Zealand, did an assessment of the communicated disease of wind turbine syndrome. And it's not a communicable disease, it's a communicated disease. It's mostly clusters in English-speaking countries, and it's communicated. People tell you about it. One of the assessments they did is they said, okay, what percentage of the populace have these basic symptoms? Sleeplessness, snoring, sleep apnea, a few other things, tinnitus. Oh, and what percentage of people who are claiming wind turbine impacts are seeing these things. Oh, it's the same percentages. It's just they're blaming these things on the wind turbine. Well, the wind turbine blades is the same thing, and the solar panel waste is the same thing. You can take a picture of it, and you can circulate it on the internet. You can communicate it, and it is visible, and therefore it's horrible. But here's the thing. Wind turbine blades and masts and solar panel stuff, by definition, is fairly chemically inert. It has to be sit outside in extremes of weather for 25 to 30 years and not collapse into dust after a couple of months.
Yeah.
Pretty much is the definition of a durable product. If it goes into landfill, a lot of it doesn't, because good news there. Well, it just sits there. It's not creating problems. But you can see it. You can take pictures of it, and people can get outraged. The challenge, though, is what is it displacing? Well, it's every megawatt hour of electricity from wind or solar displaces a megawatt hour from fossil fuels, from burning coal or burning gas.
Yep.
And the thing about that is the emissions from coal and gas are mostly invisible. You can't take a picture of them that will outrage people. You can do it with coal, because coal, but a natural gas plant, well, it's just sitting there and it might have a little steam coming out of it or something, and it looks innocuous. But here's the thing. Those blades of wind turbines, it takes about a half a kilogram over the life cycle per megawatt hour delivered. It's like in the grams level. But a megawatt hour of coal produces 800 kilograms to 1.1 tons of CO2, carbon dioxide. So every megawatt hour from coal and gas produces hundreds to over 1,000 kilograms of invisible carbon dioxide. Now, you may have heard carbon dioxide mentioned in the news once or twice, Tom. It causes something, the greenhouse effect. I think that's something like, climate change. Wind turbines displace hundreds of kilograms of carbon dioxide. I did the math. It's 4,000 to 8,000 times more mass per megawatt hour for coal generation than it is for wind turbines. But you can't take a picture of it. And for solar, it's in the same range. And here's the thing. Solar is recyclable. Wind turbine blades are recyclable. We're starting to recycle them. And wind and solar are absurdly better. So the fact that you can take a picture of them and outrage people just ticks me off. But once again, I deal with the reality of human beings. And so, yeah, we have to kind of work around this cognitive glitch we have. There is other stuff, though, in that context. I don't know why people get more fussed about fly ash from coal burning than they do about carbon dioxide. But every time I write about, but what about the coal ash? I said, it sits there. I mean, yes, it's bad, but it's not causing global warming. But, coals also produces sulfur, which creates acid rain and toxic smog that's bad for human health. Both of them, when they're burned, produce nitrous oxides, which creates smog, which creates childhood asthma, which is bad for human health. Wind and solar don't emit any of that. And for the coal people, no coal ash either. Coal ash mass per ton is much higher than the wind turbine and solar mass per megawatt hour. But yeah, it's fascinating to me, the cognitive glitches that we're subject to, and how many people, for people whose hearts are in the right places, they want wind and solar to be better. I beg you, don't share the photographs. Don't write about how important it is we solve for this. Because the question you should be asking yourself is, why aren't you holding gas and coal generation to the same standard? Why aren't you demanding 100% recycling of all the emissions from coal and gas?
Mm-hmm. Yeah.
These are much more harmful, and we could landfill every solar panel and every wind turbine blade from now for 150 years. We would be so far ahead of the game. Stop sharing the picture and creating outrage and doing the fossil fuel industry's public relations arm job for them. You aren't helping. Just stop.
We're coming towards the end. We're running out of time here now, Michael. If people listening can take away one mindset shift about electrification and transportation, what should it be?
I talked about all the various things you get out of mass timber buildings. And I
Yep.
talked about the virtuous things you get out of maximizing electrification. They are virtuous interlocking processes that benefit a lot of things. I talked about human health impacts of burning fossil fuels. You gotta make electricity cheaper than gas. Humans won't change if it's going to cost them more.
Hmm.
So make it cost less. But yeah, the thing I'll say is that over the next 30 years, everybody's life is going to get better in a lot of ways as we electrify. For the portions of damage that fossil causing us, our lives are going to get better. Unfortunately, we're going to have so much baked in global warming that's going to cause all sorts of ripple on effects that our lives will get worse in other ways. In Seville or in Vancouver, the air will be cleaner, our energy requirements will be lower, will be more comfortable. Our outdoors will be quieter. Like people who come back from China, they tell me about it. And it's like, it's so quiet. You can have a conversation on the streets because it's all electric vehicles now.
Yeah.
So,
Yeah.
anyway.
Last question for you, left field question. If you could have any person or character, alive or dead, real or fictional, as a champion for electrification of everything, who would it be and why?
Abraham Lincoln, great orator, and sharp on his feet. Somebody walked into Congress once and said, Mr. President, this is when people could just walk in and ask the president a question. President, how long should a man's legs be? Long enough to reach the ground. He had a sense of humor. His short life was cut short too much, but Abraham Lincoln would be fun.
Fantastic. Michael, if people would like to know more about yourself or any of the things we discussed on the podcast today, where would you have me direct them?
LinkedIn. And my last name is spelled Barnard, not Bernard.
Perfect. Great. Michael, that's been fantastic. Thanks a million for coming on the podcast today.
No problem, Tom. Thanks for having me back.